A patient was prescribed pain medicine to be given every 4 hours and an antibiotic to be given every 5 hours. The patient's bandages need changing every 12 hours. The nurse changed the bandages and gave the patient both medications at 6 a.m. Monday morning. How many hours will pass before the patient is given both medication and has his bandage changed at the same time? First thing we want to make sure is that we realize the fact that the patient was given both medications and his bandages were changed at 6 a.m. on Monday morning isn't very important. The only thing that's important is that all three were done at the same time. The fact that it was at 6 a.m. doesn't factor into the problem. So don't think you need to use that 6 a.m. time somewhere in your problem. You just need to know that all three of them did coincide at the same time at one point in the day. Now we need to figure out how long is it going to be before that happens again, before they all happen again at the same time. In order to do this, we need to find the LCM, the least common multiple, of 4, 5, and 12. So we're going to make a list of multiples of 4, 5, and 12. Now I'm going to start with 12 because when you're finding the LCM of numbers, it's sometimes easier to start with the bigger number, and then as you're looking through the multiples of the bigger number, think about the other two numbers and see if you find multiples that the other two numbers would be factors of, because you also want to see if that multiple will end up in their list. So I'm going to start with 12. Now, I'm also looking for a number that will show up in the list of multiples of 5. So I know I'm going to be looking for a number that ends in 0 or 5, because if 5 is also going to be a factor, it has to end in a 0 or a 5. So let's start with 12. 12, 24, 36, 48, and 60. Now, I'm stopping at 60 because 60 ends in a 0, which means 60 will also be a multiple of 5. And I also know I need a number that's a multiple of 4. Well, 60 is also a multiple of 4. So I found the first number in my list of multiples of 12 that will also be a multiple of 5 and a multiple of 4. Now I just need to prove it and make sure that 60 does fall in both lists. So now I'm going to start with the list of multiples of 5. 5, 10, 15, 20, and so on until I get to 60. And then we go with our list of multiples of 4. The 4 is going to be the longest list because 4 is the smallest number, so it's going to have the most multiples before we get to 60. So now we can see 60 shows up in all three lists. So, for instance, if I go back to the list of multiples of 12, what that means is his bandage was changed in 12 hours, it was changed again in 24 hours, it was changed again at 36 hours, it was changed again at 48 hours, it was changed again at 60 hours. So all these things are happening at all these different hours, but the first hour where they all coincide again at the same time is going to be in 60 hours. So the answer is that 60 hours will pass before the patient is given all three treatments at the same time.